Hey class, in this video I'm going to talk a little bit about the dependent samples t-test. It's also known as a paired samples t-test, and I believe that's what SPSS actually calls it. So the dependent samples t-test is used for within subject designs. This test is used when we have repeated observations or repeated measures. So we have the same subject and we measure them multiple times. You think of like a pre-test, post-test type situation. We also use the dependent t-test when we have what are called like matched subject designs. And so this is when we actually have individuals from two different samples, but we match each individuals we match individuals in one sample to individuals in another sample so that the two individuals are equivalent or nearly equivalent with respect to some variables that the researcher would like to control. This could also be naturally occurring pairs like twins or spouses, or you can match people, say, on like ability level, or looking at we have two groups of college students. We match them on, say, their gender, their ACT scores, and their age. So we can control for those different factors. Let's look at an example here. Let's walk through an example here. So a major oil company would like to improve its image following a large oil spill. Its marketing department develops a short commercial and tested on 7 subjects. People's attitudes about the company are measured with this questionnaire both before and after viewing the commercial, where higher values indicate better perceptions of the company. The data in this table below, and we want to know whether these data indicate the commercial would improve the company's image. Use an alpha level of 0.10. So notice that this is a within subject design. We have the same person, we have the same people, the same 7 subjects, and we're measuring them twice. Right? We want to know their perceptions before their perceptions of the company before they watched the commercial, and their perceptions of the company after they watched the commercial. And we're going to use an alpha of 0.10. So we're willing to accept a 10% chance here of making a type 1 error. So the first step is always to state the hypotheses. Our null hypothesis, remember, is always the hypothesis of no difference. So what we're saying here is that the difference, both before and after they view the commercial, is the same. Their perceptions stay the same. And if you want to write your hypotheses out in words, that's fine. Just because I'm using symbols doesn't mean you have to. You could write this null hypothesis as, people's perceptions do not change after watching the commercial. That would be essentially what the null hypothesis is. We're going to set our alpha level. We were told to use an alpha level of 0.10, so we're willing to accept a 10% chance of making a type 1 error in this case. We need to compute our test statistic. So we need to know the degrees of freedom. The degrees of freedom for this test are the number of pairs. So basically the number of subjects you have minus 1. There are 7 subjects, 7 pairs. Cut that from 1, we have degrees of freedom for 6. You can see the formula for the dependent samples t-test, and I'll work it out by hand here in the notes. Then you'll see why we actually prefer to have the computer perform the test for us. But it's basically the difference between the means divided by the standard error, which is the standard deviation of the 2 groups. So we add the standard deviation for the the variances for the 2 groups together, and then we're going to subtract 2 times the correlation between the groups times the standard deviations for both of the groups, where R here stands for the Pearson correlation between X1 and between the two excuse me, between their 2 ratings of their perceptions. You can see I work this out by hand. We get a t-value of negative 2.26. Well, we need to know what to compare that to. We can go back to that p-value calculator that's linked here. We put in our t-value, negative 2.26, put in the degrees of freedom, and we get our p-value, 0.0645. We compare our p-value with our alpha level of 0.1. Since our p-value is less than our alpha level, we're going to reject the null hypothesis that there's no change in perceptions and conclude that there is a difference in perceptions. It seems that people improve their perceptions of the company after watching the video. Notice that if we had used an alpha of 0.05, we would have come to a different conclusion, right? We would have failed to reject the null hypothesis and conclude that the commercial didn't change people's attitude. This is why it's important that you decide on your alpha level before you actually conduct your test. We go through the same process again. We're going to calculate our confidence interval. This time it's just the difference between the two means times a critical value times the standard error of the difference, which is just that denominator here again. And we get this 90% confidence level. So what this is saying is that the commercial tended to, if we were to, sorry, I'm getting tongue-tied here. What the confidence interval is telling is giving you your estimate of what the difference may be in the population. So the difference in people's opinion could be as low as 0.42 or as high as around 6. It could be a 6-point change. So it's giving us a range of where the population parameter might lie. Remember, we only tested this on a sample of 7 subjects. And we want to know, well, if we were to implement this on a larger scale, what impact this might have on the population. This is our estimate of what the population impact might be. You would get the T critical value here from this online calculator here. Then we go to that website, you give it the degrees of freedom, what confidence level you want, and it gives you the T critical value to use in the confidence interval calculation. This is another one you don't have to worry about because SPSS gives you the confidence interval. One thing that SPS doesn't do is effect sizes, but I made the Excel spreadsheet for you here. So you would enter the your sample size and your sample size and your T-bar. Was it 2.66, I believe? Yes, 2.26, sorry, 2.26, and you get a Cohen's d of 0.85. So what's that saying is that people's perceptions of the company improved by around 0.85 standard deviations after watching the commercial. And according to Cohen's rules of thumb, he would say that was a pretty large effect. You can also get an omega squared for this. We put in 2.26, and it was 6 degrees of freedom. So what this is saying is that around 37% of the variability in people's perceptions of the oil company can be attributed to the commercial. So around 37% of people's changes in attitudes of the oil company can be attributed to that commercial. So the assumptions for the dependent t-test, observations must be randomly selected. That's, we have to select randomly from a population if we want to make inferences back to that population. So observations within each treatment must be dependent, right? So that's the idea of we're having the repeated measures, or that we have a matched pairs set group. And then we also make a normality assumption for here too. But generally, we're not too worried about this, especially as sample sizes increase, the normality assumption becomes less problematic. You can see here my example write-up. So you can see how you would write up a example of how you'd write up these findings for a traditional APA-style journal article. Check out the video on how to run this in SPSS. I also have a document on Canvas on how to run it in SPSS. If you have any questions, please shoot me an email or post on the message board. I'm always happy to answer. Thank you.